Region E. Based on the voltage transfer characteristic curve, the inverter's input voltage is greater than VDD plus VT not P. Therefore, the region in green indicates the NMOS gate source voltage. Based on the KVL analysis at the inverter's input, we know that the gate source voltage of the NMOS plus the gate source voltage of the PMOS will be equal to VDD. Since we know that the gate source voltage of the NMOS is the region highlighted in green, the gate source voltage of the PMOS will be the region highlighted in orange. As we know that the threshold voltage of the PMOS transistor is defined as VDD plus VT not P. Therefore, the threshold voltage of the PMOS transistor will be the region highlighted in brown. By visual inspection, we can see the NMOS gate source voltage is greater than its threshold voltage. Therefore, we can see that the NMOS transistor is turned on. On the other hand, the PMOS gate source voltage is lesser than its threshold voltage. Therefore, we can see that the PMOS transistor is operating in the cutoff region. Up till now, we only know that the NMOS transistor is turned on, and the PMOS transistor is turned off. To complete the analysis of the NMOS, we need to determine, is it operating in the linear or in the saturation region? To determine this, we need to know 1. NMOS drain source voltage. According to the IV characteristic, the drain source resistance is inversely proportional to gate source voltage. By visual inspection, we can see that the PMOS gate source voltage is much lesser than the NMOS gate source voltage. Therefore, we can say that the NMOS drain source resistance will be much lesser than PMOS drain source resistance. At the same time, we also know that the PMOS transistor is turned off. With this information, we can conclude that the inverter's output voltage will be equal to 0. If the inverter's output voltage is equal to 0, the drain source voltage of the NMOS transistor will be equal to 0 as well. Based on the KVL analysis at the inverter's output, we know that the drain source voltage of the NMOS plus the drain source voltage of the PMOS will be equal to VDD. Since we know that the drain source voltage of the NMOS is equal to 0, the drain source voltage of the PMOS will be equal to VDD. Therefore, by visual inspection, we can conclude that 1. NMOS is operating in the linear region. In region E of the CMOS inverter, the NMOS transistor is in the linear region. The PMOS transistor is in the cutoff region.